students? We go back to the, okay, so that was the last one. Now let's introduce ourselves to the new topic we are going to be doing. Okay. Okay, can you see my screen?
Yes, ma'am.
Okay, okay, that's good. So, students, everything we finish, even if we finish prelim, we finish midterms, just try to recall those things because you see, I am teaching it now, but how long ago did I do this? You never know, you might have a chance to have a side job and you could give some information to a kid. Okay, so these things which we learn, it's not that we are going to use them in our career, but it's part of us as intellectuals. When you are sitting with people, you can communicate properly with them. They say something, your method of analysis is good, and you can provide something which is called sense. It makes sense. So it's not like, why am I learning 1 plus 2? What will I use that for? No, it's just to make you an intellectual, somebody who can be able to make decisions when you are in your whatever career you have chosen to take. Okay, so now, excuse me. We are going to we will be doing 2 topics. One is going to be from algebra, another one is going to be from business math. So we have operations on algebraic expressions, and another one is about merchandise and retailing. Okay, so first we need to have a background on what we are going to do in operations of algebraic expressions. The main topics here is linear equations and linear inequalities. When you say linear, it means the equations we are going to be talking about, if you plot it on a graph, it's going to make a straight line. To make a straight line, it will not be a curve. So which means we are going to be dealing with only equations which we call in the first degree. So you see, I've said so many things which we need to know about before we start the major topics. Okay, so let's look at what is an algebraic expression. That is going to be our first topic. So when you say algebraic expression, anything, any tool which is used in mathematics, all numbers are considered as algebraic expressions. So sometimes, because we don't know what the number is going to be, we are going to assign letters. Usually they use the English alphabet to assign a letter to represent a number which is unknown, and those representatives are what we refer to as variables. So if you see something like a plus b and plus 3, so a and b are variables because you don't know what they stand for. Okay, so when you talk about an algebraic expression, that is it. It could be just a single, just a letter, like it's usually in algebra, they represent variables with X or Y or Z. I say Z in English, but Americans say Z. Or sometimes they use ABC. You can use any letter from the alphabet to represent an unknown, and that will be referred to as a variable. So it could be X, Y, D, P, whatever you want. But usually in mathematics, the standard letters they use, if we don't need so many, it's X, Y, or Z. And then they'll start with A, B, C to represent a variable. Now, is that an algebraic expression? Yes, an algebraic expression could be just a single variable, or it could be 2, xy, or it could be 3, depending on how you want to put it. An algebraic expression also could be just a number, 1. It's an algebraic expression. It could be 2. It could be 1 million. It could be 12. It could be 20. All these are algebraic expressions. So this brings us to the terms, how we call them. So this is a variable, and if it's a number, it's referred to as a constant. Now, you could have a combination. You could have 2x, because I don't know the value of x, it's unknown, but I want to have two of them or something, so it could be 2x. So this is a variable and this is a constant. It is also referred to as an algebraic expression, but it's a combination of a constant and a variable. Okay, so that will take us. This is not so important for our thing. We just need to know it so that we'll be able to understand the linear equation. Okay, so now you've seen, I've already expressed that a variable could be just a letter, or it could be a number, but it can also be in a form of what they call, of course we say express, it could be in a form of an equation, which we are going to be looking at. For instance, if I had 2x plus 1, is that an algebraic expression? Yes, but in this case, we have two algebraic expressions in one equation. So if you have an algebraic expression which is just singular, it's just alone, that one is referred to as a monomial algebraic expression. Mono means one. Now, if you have two of those expressions in one equation, then that expression is referred to as bi, because they are two binomial. Okay, binomial. So what is a binomial? A binomial is an algebraic expression that consists of two terms. So these are referred to as terms, each one. So a monomial has one term, a binomial has two terms. Now, how will I know that it has two terms, it has three terms? Because what if I'm given something like this? 2x, y, z. How will I know that this is a monomial, a single term algebraic expression? You will know that if the terms in the expression are not separated by either a plus or a minus. If an expression doesn't have any fundamental operation of a plus or minus, then you can consider that as a monomial expression. So we don't consider multiplication and division, only addition and subtraction. So the moment a plus or minus is introduced between two terms or two algebraic expressions, it means it's going to become more than one. It will become more than one termed algebraic expression. So now we have here a plus, it could be a minus. So this one too could be plus b, and then maybe plus 3. Then because we've introduced another operation, it means we are going to have 3 terms in one equation, and that is what referred to as a trinomial expression. Tri standing for 3. Tri stands for 3, by 2, and mono is 1. So this is a 3-termed algebraic expression, is referred to as a trinomial. Now, what if I have more than 4 terms in an expression? So that is why they came up with what we call polynomial, because we cannot go on saying phonomial, phinomial, my goodness. So we only ended at trinomial because it's easier. Trinomial, 3-termed, binomial, 2-termed, and monomial, 1-termed. The moment it becomes more than 4 terms, it's referred to just as polynomial. Now, what is a polynomial? If you're going to be defining a polynomial, you define monomial is a 1-termed algebraic expression. Binomial, it's a 2-termed algebraic expression, and a trinomial is a 3-termed algebraic expression. But what about a polynomial? A polynomial is an algebraic expression which has two or more terms. I'm going to repeat that. A polynomial is an algebraic expression which has two or more terms, which means a polynomial is any algebraic expression which has more than one term. It has more than one term. So the monomial is the only expression which is not referred to as a polynomial. All the others are referred to as polynomials. So is a binomial expression polynomial? Yes. Is trinomial polynomial? Yes. Anything which has more than two terms is referred to, more than one term is referred to as a polynomial. Now, in terms of our studying and learning, if you are asked to define what type of expression is a two-termed algebraic expression, please do not say it's a polynomial. Why? Because we would not know whether you're referring to three-termed or four-terms. The fact that it has its own name, refer to it as its own name, which is binomial. Will you be wrong to say it's a polynomial? No, you are not wrong, but it's too general a term. Because when you say polynomial, people understand the expression has more than three terms. That is what they will think, that it has four terms or five or six. So if you're given a three-termed or two-termed expression and you're asked to define it, give it the term we know, which is either trinomial if it's three and binomial if it's two. You are not wrong when you say polynomial, but in my class, if you say polynomial, you're going to get 3 out of 5 points. Because I'm like, can you give me another more specific term? Okay, so now we understand. So you have, for instance, in this expression here, so this is the constant part. If you have an expression like 2x, so this is referred to as the constant part, and this is referred to as the variable part. In other words, sometimes they'll say this is the numeric part and this is the literal part. But these things, I'm just giving it to you for your own information. I don't think I'll be asking you about things like that. I just want to bring out the type of expressions and then the types of expressions, so that when we have our linear equations, you will be able to understand if I say it's a monomial, binomial, so you know that it has 3 terms, the equation, or it has more than 3 terms. Okay, so let's move on. We are still doing background information. So now we looked at the types. We learned about mono, bi, and tri, and poly, of course. Now let's look at what they say, degree of an algebraic expression. What does this stand for? So before I say that, we are only going to be dealing with expressions which are first degree in our linear equations. Because when you say linear, as I said, if you plot it on a graph, it's going to give you a straight line. So now we talk about the degree. So any linear equation is of the first degree. What does that mean? It means that we don't have any exponents on the variables. For instance, if I have an expression 2x plus 1, or even just if monomial, they will ask you, what is the degree of this expression? When they ask for the degree, they are referring to the variable part. So any expression which doesn't have any variable is referred to as a 0 degree expression, because there is no literal part. Because the degree is always referring to the exponent on the variable part. So this one is referred to as a first degree expression. How do I know it's first degree expression? Because the exponent of x is 1. We don't write it there, right? We don't write the exponent here, but we know that we have a 1 here. Any number has exponent 1, meaning it's just the number. So that's why it's referred to as the first degree. So all the equations we are going to be using in our linear equations in our topics are going to be first degree. So if you introduce, let's say, now this is first degree. What if it was written like x squared? Then this will be referred to as second degree. So how do you find out what degree it is? Look at the exponent of the variable or the literal part of the expression. Now, what if I had something like this? 2x plus x squared. What if I had something like this? And they ask you, what is the degree of this expression? So you find that I have two variables. One is 1 degree and the other one is second degree. So how will I know what is the degree of my expression? You go to the one which has the highest number. So since this x has a 2, therefore this is referred to as a second degree expression. Now we are going to be confused. What if I have 2x y? And they ask me what kind of degree, what is the degree of this expression? In this case, if there is no addition here, because there's no addition operation here, this is multiplication, this is addition. Now, if you have something like this, then we are going to add the exponents of the two variables, and that is going to be the degree of our expression. In this case, since y, there is nothing, so it's 1 and this is 1, therefore it will be a second degree expression. If you had something like this, to x, maybe y cubed, what is it going to be? This will be a fourth degree expression. Always add them. But if it were 2x plus y cubed, what will be the degree? Third degree. Because this has the highest, there is a fundamental operation here, so we cannot just add this one to this. So this is 1, this has the highest, therefore this expression will have a third degree. It will be over third degree. Okay, but remember, I just bring this for your own information so that we then don't get confused if we are talking about a linear equation of the first degree. Oh my goodness, so you become confused. So I hope you put this in your minds to remember it when you're talking to your mathematical friends. Okay, okay, so that is overview. Let's look at another. So we looked at the types, monomial, polynomial. Now these are the two introduction here. Now let's go to the core subject of our topic today, and that is linear equations in one variable. First, let's ask ourselves, what does it mean when they say a linear equation in one variable? And that is going to be our topic. We are not going to have more than one variable, different variables in one equation. So when they say in one variable, it means our equation has only one variable. For instance, I like the 2 always, 2x plus 1. So I have only x. I will not have a y or a c or a z. So it's only 1. And remember, we are talking of only the degree is always 1 because it's linear. It's going to give us a straight line. Okay. So when you're given something like this, and yes, so you understand this is a linear equation. How do I know that? It is in first degree equation. Therefore, if I'm going to be plotting anything online, I mean on a graph, it's going to give me a straight line, Okay, so what is an equation? What is an equation? So when you talk about equation, you bring in your mind equal sign, equal. So it means if I have something like this, this is an expression. It's not yet an equation. It's an algebraic expression. The moment I introduce an equal sign, it's equal to maybe 5. then this is an equation. It becomes an equation. So because I've introduced an equal sign, so every time you have an expression, algebraic expression with an equal sign, that is referred to as an equation. We add this linear, as I said, it's about graphing, so you get straight line. A straight line if you're going to be plotting the points on a graph. So an equation is an expression, an algebraic expression, which is equating one side of the algebraic expression to the other side of the algebraic expression. Remember, 5 is an algebraic expression. 2x plus 1 is a binomial algebraic expression, and we are equating them, so we come up with an equation. Now, when given something like this, you would like to solve it, what we call solving, meaning find the solution or evaluate, find the number which will be put in x so that it will make this equation true. So you want to find a solution for this. So any values of x will be considered as the solution, or if there are many, which will give us the answer to us an answer 5, it will be a solution set. So solving this is what we call evaluating the equation. You'll be substituting a number here to come up with a number which will give you 5. So in this case, it's so obvious that x is equal to 2 because 2 times 2 plus 1 will give us 5. So what we've just done is evaluating this equation to come up with a solution set, which is x is equal to 2. So this is only one value, so it's just the solution. If there were many, then we are going to call them solution sets. So what is it we want to learn here? To understand what is an equation, it is an algebraic expression which equates one side of the expression to another side of the expression. Okay. Okay. So students, all this is in your handouts. Read it and understand the literature so that when it comes in your matching type, you'll know what to do. Okay, so this one I brought it. As you can see, these are not equations. This is not an equation in one variable, but I wanted to state what evaluation of values of an algebraic expression, what it means. So if you're given an expression like this, and you're also given values to substitute, it means you're going to be evaluating the answer to this expression. So you're given, if you're given like 4x cubed minus 2y cubed, and then they will ask you to evaluate this expression if x is equal to 2 and y is equal to 3. This is very simple. That's why I will not spend any time on it. You just have to put these values here. 2 times 2 times 2 is 8 times 4, 32. What am I doing? Evaluating. 3 times 3, 9 times 2, 18. That is called evaluating. Substituting the values which are given to you to find what is the value of the expression which you have been given. What is it we are trying to learn here? Language. What is the language? What does evaluating of evaluating an algebraic expression mean? I'm given solution, a solution set, then I am supposed to substitute the values into the equation to come up with the final answer. Okay. Okay. Okay, now we are going to do some finding some solutions for things. Okay. Now, when you're going to be evaluating, finding solution to your solutions to a linear equation. I hope you're not sleeping, students. Okay, so let's do some evaluation here. Let's see, we are given we have what's this? If you're given 5x, given 5x minus 6 is equal to 15. Now you need to find the solution for this one. I think students, you did this in high school, I think so, where you do transposing and everything to find out what is the value of the variable you've been given. So this is a very simple thing. If you're given this, what are we going to do? So we have the property of addition, which says that what I add on one side, I'm going also to add it on the other side. So to be able to find the value of x, what the best thing to do is to leave the variables on your left side and put all the constants on one side. So in this case, to be able to remove the 6, what are you going to do? You'll be adding the 6 here. What you add here, you also add it here, because it will be like 6 plus 6 will be 0. So I remove the 6. So if I added a 6 here, I need to add it here also. So this will give you 5x is equal to 15 plus 6. And this will give you 21. 5x is equal to 21. Therefore, do the division, go to the division. So we want to isolate x to be alone. What am I going to do? I need to remove the 5. How will I be able to remove the 5? By dividing this expression by 5. So if I'm going to divide this expression by 5, I need to do the same thing this side. So this will give me, divide by 5 here, divided by 5, it will give me x is equal to 21 over 5, or if you want to divide it, will be 24.2, if I'm not saying. So x is equal to 2. But students, I would like to tell you something. If I give you, of course, I'm not going to give you something simple like this, but if I gave you something like this, you don't need to go all through this one. I can just see it. You could go straight. 5x is equal from here without going even here. You can go straight because you know it already. It's very simple. 5x is equal to 21 and x is equal to 4.2. I mean, it's so, because you can, I can see that you know what you're doing, because this is so, I'm sorry to say, very elementary to just go like this. I think you agree with me, students. Okay, so you could go straight from here to here, and here, and that's it. Okay. Okay, so please read about this if you need to, but I am sure everybody knows this, because it's just about transposing what you do this side, you do with this side, to be able to come up with the value of the variable in the expression. So what is most important here? This is finding the solution to the equation, to the linear equation. Of course, the ones I'll give you will not be like that, not as simple as that, but it is the same theory. Okay, so let's look at one of these here. What if you're given, the ones I gave here, I'm going to do this one. So the others, please practice by yourself. So let's do this number. If we are given x, so you can use addition, the property of addition, subtraction, division, to be able to come up with an answer. So x plus 1 divided by 2 plus, so I can do it like this because I can write, I put the grouping symbols so that it's understandable. So this is equal to 3. So when you look at this, as if it's so complicated, but actually it's not. How will you approach this? So the way you make your strategy is very, very important to solve something like this. This is actually a linear equation. It's just that it was complicated with fractions, but you can see it's a linear equation because it is in one first degree. Okay, so I see I have x plus 1 over 2 plus 2 is equal to 3. What is the first thing you're going to do? Because you want to isolate the variable to be on this side, left side, and I want to put all the constants on this side, variables this side, constants that side. When I look at this kind of equation, the first thing to make the shortest cut possible, what is the first thing I'm going to do? I'm going to transpose the whole number 2 to the other side. That is the first thing I'm going to do. So that I'm going to have x plus 1 divided by 2 is equal to, how did I transpose this? By using the subtraction property. So subtract 2, I'm going to remain with 1. If you do not understand, you will ask me, students, please ask me. What did I do? I just remove this one, I take it the other side, I remain with 1, and my equation is now like this. So where am I aiming? Objective is to isolate the variable. So I need to isolate x, but it's divided by 2. So what am I going to do? Remove the 2. Use the multiplication property. I'm going to multiply each side by 2. So this side, when I multiply it by 2, it's going to cancel out 2. I'll remain with x plus 1. And the other side is going to become times 2, will become 2. Very easy. I'm done. I'm going to isolate x by removing the 1. If I removed 1 here by using the subtraction property, I remove 1. I have x is equal to 1. If you want to see if it's correct, you substitute it back here. So when we do 1 plus 1 will be 2 divided by 2 is 1. 1 plus 2 is equal to 3. So we are correct. How many steps did we take? 1 and 2 steps only to be able to get this one. Is there anybody who is wants to ask me about this? Okay, now I'm going to repeat. When you are solving these kind of equations, even they complicate it no matter whatsoever, the first thing you need to ask yourself, what is it I'm going to solve for? It is the variable. Where is it? If it's this side, please move it this side. But one thing is, make sure that your variable is always positive. What if this was 1 minus x? Make sure that it's always positive. So if it's negative, put it the other side so that it will become positive. Make sure it is always positive. That's number 1. Number 2, always try to manipulate it in such a way that it is on your left side, because it's easier than if it's there, because it's the one I'm looking the solution for. It is always on your left. That is number 2. Number 3, try to remove all the, what's this? The constants, move all of them to the left. And make sure that your variable is, it is only the variable without any, like it's not 2x or it's not. Make sure it is just the variable, it's 1. The coefficient or the numeric part is 1. Make sure that the numeric part is 1. Then move all the constants to the right side. And that's it, you're done. It will be very easy. So what is the most significant, important thing here? To have the shortest solution as possible. Have the shortest solution as possible. This one, because if we wanted to waste time, you'll go, okay, I move this there, then I'm going to multiply this by this, and you know. So try to go in a procedure which will give you the shortest solution as possible. Because if I started with the multiply everything by 2, and then this will become 2 also, you see, it will be giving you too much trouble. So analyze it in such a way that it will give you the shortest procedure, shortest process as possible. It will look neat and it will look like you really know what you're doing. Okay, so you have these other numbers to practice. If you find that you cannot do any one of them, you just come to me. We can do it together. Okay. Okay. Is there anyone who wants to say something, students?
Ma'am, I have a question, ma'am. Good morning.
Yes, sir. I like that.
Ma'am, do we really need to make a short solution as soon as possible, other
No,
than
no, no. No, sir. No. You don't need to make the short solution.
oh,
Yeah, in
so
fact, thank you
you can
so much, sir,
consider
for
it.
asking
You
that.
can consider it, ma'am, if I made it long.
Even if you made 3 pages.
Okay, ma'am. Okay, ma'am.
Yeah,
Thank
yes.
you.
Thank you for asking that.
Thank you.
Students, listen, your classmate asked a very good question. When I'm saying that, make sure your solution is very short. No. I am just saying that it will be, I thought it would be easier on you, but no. Students, you want to solve it long, it's okay, as long as the process is logical. Okay? Very good question, sir. Very good. It doesn't matter if your solution is from here to kingdom come, but may I tell you, what if you are in board exam and then you take so long, my God, you might not finish. But if you're making it long makes you comfortable, that I know where everything is coming from, then it's okay. It's okay, students. That was very good. I was not thinking about that it will come out like that. Please, you don't need to make short like I did. You can go as long as possible, as long as we are going to come up with the same answer. Okay? And you make it neat so that I can follow what you're doing. Okay? Make it neat so that I can follow. So don't care it's so long, but you have the answer. It's okay. Because the problem here is I really need to see your solution. I need to see your solution. So I was pitying you that you'll be spending so much time writing. That's why I say make short. But no, you don't need to make short. I'm very happy with that question. So I will not make the same mistake in my other class. Okay, thank you so much. Do we have anything else you want to say before we move on? Okay, thank you for that question. I am very happy about that. Okay, so let's move on. Now, okay, so what we are doing here was finding solution to our equations, linear equations. They will be given to you in different twisted, but actually, and what is the objective of doing that? To see how articulate you are. How articulate are you in solving problems in your company? That there is this problem, we need to do this, and they need it in 5 days. Can you find a procedure so that you'll be able to finish in 5 days? So that is the same thing we are trying to do here, to make your mind sharpened for those instances which can happen in your future career. Okay, so let's look at the second topic. So the topics we have, number 1 topic was finding solutions for linear equations. Now we want to translate, remember language and symbols, students, we want to translate algebraic symbols to word statements, and then we are going to do the vice versa. I am not so fond of this one, because if you're going to be translating, for instance, we have here a good example. Okay, let's do this. Okay. For instance, we are going to be translating this algebraic expression to words in word statement. There are so many ways you can do this. So it's not only that you can write it in one way, but there are so many ways you can be doing this. That is why I don't give questions like this, because everybody will be writing different and I would have trouble checking it. So if you're given an expression, let's just do it to see if we understand what it means. You're given an algebraic expression 2x plus y. How would you translate it to a statement, worded statement? Okay, so you know what plus means. It means sum. And you know what 2x means. It means it's a product, because 2x is 2 times x, and y is just standing there alone. So you could say the product of 2 and x, the sum of y and the product of 2 and x, or the product of 2 and x added to y, or the sum of y and the product of 2 and x. So you see, there are many ways you can write it. That is why I don't give questions in the exam like this. But I would like to hear, can somebody tell me, how would you translate this? Because this one, okay, can you say any other way? How could you say this? This one, without using sum or plus, or how would you say this one in English? Anyone? Anyone? Is there anyone who can say, using many words? You can use twice, you can use increase, you can use, yeah, How would you say using twice and increase? Those two words. Express 2x plus, yes.
Reorder to, so the highest order terms are first.
No, because the expression is 2x plus y. Okay, how can you put it in a worded statement so that people will still understand it's 2x plus y? Because you could say twice x increased by y. That is another way of writing it. Okay, I've said it. Twice x increased by y. That is the same as 2x plus y. Why I need you to understand this, because you are going to be translating worded statements too. That one will be, I will be giving it to you. What we are saying from here, you're going to make it into algebraic symbols. So I need you to understand the worded problems. So 2x could be, you could read it as the sum of twice x plus y. Or you could read it as 2 times x increased by y. All those things mean 2x plus y. Or you could say y more than twice x. So it means y plus 2x. You see, different ways. Or twice x plus y. What about this one? X minus 3y.
May I try?
Yes, x minus 3y.
X decreased by 3 times y.
Wow, very good, very good. I am very sad because I don't give bonus points in midterms, finals.
It's okay, ma'am.
Yes, but this is beautiful. What is that again? X
Decreased by 3
decreased
times
by
y.
3. Yes, x decreased by 3 times y. That is a very good one. Or you could say x diminished. It depends on what words you use. X diminished by thrice y. See? So please practice that, saying those things, so that you will be able to translate the words to symbols. And that's what we are going to do. So we have 3 topics here under linear equations. 1, finding the solution sets. Number 2, translating the symbols to statements. And number 3, translating the word to symbols. And that's what we are going to do. Very good, I have very articulate students. Okay. Word problems involving linear equations. Now, we need to find first, you're going to write the algebraic expression, and then you're going to solve it. So we have this one. It says, find the number which, when decreased by 3/4 of itself, equals 28. I need to find something first, because there is, this is inequalities already. Okay. First thing, you need to write the equation using symbols. So you need to understand this. So it says, find the number which when decreased by 3/4 of itself equals 28. So I'm going to do this one, then the next one, you people, you're going to do it. So what is the first thing I'm going to do if I'm given something like this? Find the number which when decreased by 3/4 of itself equals 28. I'm going to give my number, unknown number, and unknown. So I'm going to say, let the number be n. So I'm going to say, I found the number already. The number is n. So n decreased by 3/4 of itself equals 28. So here I'm saying I found the number already. In fact, I write it. The number is the number. So my number, the number is n, is n. Okay, the number is n. Now I'm going to put it here. N decreased by 3/4 n equals 28. I'm going to make that as an equation. N decreased by 3/4 of n equals 28. Bingo, bingo, you have 5 points. Very good. I have the equation already. Now, this question is asking me to find that number. The number, this is a variable. I just gave variable. I need to find what's n. So n is whole number, 3/4 is the fraction of n. So it is like you're saying n over n minus 3/4. I'm going to remain with what? What will be the answer here? Students, what is the answer? N minus 3/4 n is, oops, okay. Okay, it's good. I find out it's a little thing. Now, you have two variables, n and n. They are the same. This is the same as, if you remove the n, can we remove the n? Remove the n. If I remove the n, there should be a 1 here. Why? Because it's whole. This is fraction. This is whole. So it's the same as saying, what is 1 minus 3/4? What's the answer? 1 minus 3/4. What will it give you, students? 1 whole. 1 whole minus 3/4. What will remain? 1/4, right? This is 1/4. This is 1/4. And this is 1/4. This is 3/4. So I remain with 1/4. If you want, use the, the long thing. 1 minus 3/4, the 4 is the denominator, and then 4 minus 3. But we know that this is 1 whole. If I take out 3/4, I'm going to remain with 1/4. Okay? But remember, this was of n. Therefore, this is 1/4 of n. Okay? So, 1/4 of n is equal to 28. So what did I say? Eliminate the constants, put them on one side so that you can solve for your variable. So since this is n over 4, I'm going to multiply each side by 4 to come up with my n. So 4 times 1/4 n is going to cancel out the 4, remain with n. 128 times 4 will give me 4 times this is 8 plus 3, 1, 1, 2. I think 4 times 8, 32. 4 times this is 8 plus 3. So therefore, my n is equal to 1, 1, 2. Do we want to prove this? Yes, let's try to prove it. Oh, am I correct, students?
Yes, ma'am.
Yeah, I'm correct. Okay, so let's go. So n, when n is 1, 1, 1, 2 minus 1, 1, 2, 1/4 of this, will it give me 28? What is the answer? What is 112 divided by, am I correct? 112 divided by 4 will give us 28. Am I correct, students? Hello, are you there? Anyone? Is this correct? Is it correct, ma'am?
Yes po.
Yeah, it's
112 divided by 4 is equals to 28.
28, but it's 28, so there is something wrong. 3/4 of itself equals 28, so it should be,
Ma'am, 84.
no, so it's wrong. It cannot be a thing. 3/4. Ah, yeah, sorry. Mistake. This is equal to, I'm sorry, I am the one who made a mistake here. So we are going to substitute this n here. So we have, what is n equal to? 1, 1, 2 minus 3/4 of 1, 1, 2. What is 3/4 of 1, 1, 2? Students, compute. Sorry. I removed this so that we are not confused here. 3/4 of 112 is 84. Am I correct? 1, 1, 2. Yeah, we are correct. I became confused with the 1/4. Okay. What is 3/4 of this? 28 times 3 is? 28 times 3, is it 84? Hello? Is equal to 28. 28 times 3 is, yeah, am I correct? 28 times 3 is 84. So 112 divided by 4 is 28. 28 times 3 is 84. Am I correct? Is it correct?
Yes.
Okay. So we are correct. So that the n is equal to 28. N is equal to 28. So your answer sorry. N is equal to 112. Your answer is N is 128. 112. That is our N. Okay. Okay. I became confused with this. Okay, so can we do number 2? It's not difficult, students. It's very easy. You will see, you will be able to do it. We have many numbers to do. Can we do number 2? I do number 2, and then you are going to practice number 3. So let's do number 2. The sum of 3 consecutive numbers is 42. What are the numbers? So you need to formulate an equation using variables. The sum of 3 consecutive, what does consecutive mean? Numbers coming up one after the other, okay? It means coming after the other. So you will have, if you have 1, what will be next to 1? 1, next to 1 is 2, next to 2 is 3. So they are consecutive. Okay, so we need to analyze this very well. What is the first thing you're going to do if you're reading problems like this? Give the variable a letter. Get a variable. The sum of 3 consecutive numbers is 42. So I'm going to say, let my first number be n. So the first number is n. If the first number is n, what will be the second number, students? What is the second number? N plus 1. What will be the third number? N plus 2. Remember, the variable should be the same because we are dealing with linear equations in one variable. So you cannot say the first one is A, the second one is B, the third one is D. No. If you can be able to do that and come up with the right answer, it's okay, but it's better to use the same variable. They are saying there are three numbers. So the first number, if the first number is n, the second number will be n plus 1, the third number will be n plus 2. So if you want to substitute, what if n is 50? So number 2 will be 51, number 2 will be 52. So they are consecutive. Now, what is the premise we have been given? The sum. They've been given, what if you didn't know what sum means? But we know what sum means already. So we are going to use this to make our linear equation, our equation. So what do we know? We know that first number plus second number plus third number is equal to 42. Therefore, I'm going to use my numbers. N plus n plus 1 plus n plus 2 equals 42. The moment you have these students, bingo, bingo, you're done. You know already. So now you're going to do what was our first topic, solution to the equation. What did we say? We need to put all the variables on the left side, and we need to put all the constants on the right side. So let's remove the brackets. N plus n plus 1 plus n plus 3 equals 42. Wow, very nice. Now, add your n's. Remember, you cannot add n to a constant. Variables with their variables and constants with their constants. You cannot add pigs to the goats. There is a goat here, you know. Okay, okay. So n plus n plus n will give me 3n. 1 plus, oh, where did I get 3, students? You should scream, Mom, it's not 3, it's 2. N plus 2. Okay, this is 2, no, 2. So we have two constants, 1 plus 2, 3 is equal to 42. Slowly, slowly. So, because even if we know this is divisible by 3, but let's do it slowly. Okay, we transpose the constants which we can remove. Let's remove it, put it on one side. So let's remove the 3 so that we leave n alone here. So we have 3n. Let me put it up so that we can. Okay, so we have 3n. What am I doing? I'm removing the 3. How will I remove the 3? By the subtraction property. Minus 3, this will be 42 minus 3 will give you 39. Did you understand what I did? I removed the 3 by subtraction, subtract 3. What you do here, do it here. Subtract 3, I'll remain with 39. So how will I make n remain alone here? By dividing by 3. When I divide 3 here, I need to divide 3 here. So 3n divided by n is n. As I said, please use your long method. If you want to write it here, write it, put it there, n over 3, this over 3, so that you understand what you're doing. I am just making shortcut because I know it already. But if you want, put divided by 3, divided, then go on and on. Make as long as you want, as long as it's logical, and you understand. So I divided by 3, I remain with n. Divided by 3, I remain with 13. So therefore, my n is equal to 13. Is this my answer? No, it's not my answer. The question is find the numbers. Find the numbers. So what was the first number? First number is 13. Second number is 13 plus 1, this one, 14. Third number is 13 plus 2 is 15. You want to check if you are correct. 13 plus 14 plus 15. Is it equal to 42? 13, 27. 27 plus this, bingo, bingo, 42. So you are correct. So your answers are these ones, not this one. The answer is this one. 13, first number, and it doesn't matter one number. You just say the numbers are 13, 14, 15, or if you want to say the numbers are 14, 15, 14, 15, 13, it's up to you, as long as they are 13, 14, 15. Okay, do we need more? I think not. Students, if you want more examples, you'll ask me again. I leave you to do the others, okay? You practice. This is for your practice. Let's go to the last topic. If you want to practice, we have more days. I can extend this. I can extend it, okay? But at the moment, can we move on? Do you want we move on, students, to inequalities, or you want we end here? We will do inequalities next meeting. Hello? Students, are you there?
Yes po.
Everybody is so quiet. Okay, I need to look at you. Hello? Hi, students.
Hello, ma'am.
Yes, ma'am, we're here.
Okay, I am asking a question. Do you want I continue with the next topic, or you want, let's stop here for a while. We'll do again next meeting the other topic, or can I go on? We still have 30 minutes.
Ma'am, are you gonna give the the seat work and quiz na po?
Yeah, if I'm going to finish everything, I'm going to give you the sit work, but if I don't, I'll give it next meeting. Because we still have a lot to do, another topic. I think, okay, let's stop here. We'll do linear inequalities, and it's kind of also difficult, not difficult, but you know, a lot to talk about. Okay, now I've seen, because you know, I am very sorry, but do you know that your class is like my experiment? It is like you are the ones, when I'm teaching you, I'm going to determine how long I'm going to stay on a topic, because you are the first. You are the first for this topic. When I was doing it, I was like, is it too much for one day, or, but I think it's long. So what are you going to be doing to practice that one? Next meeting, I'm going to introduce inequalities. Okay? Then I'm going to give you but today is Thursday. So next meeting will be your sit work and quiz. And it's quite, it is a brain twist. How are you finding the topics? Are they difficult? Is it difficult?
Yes, ma'am, it's difficult.
Okay. And it's Mr. Trias.
It's a lot to process, ma'am.
A lot to process. Okay, so this is a good thing. Very good. Thank you for telling me that. So which means you need the whole weekend until Monday to process. So if I'm going to add more topics, the more you'll fall over your faces. Because if I give you, it means you need to submit your sit work and quiz on Monday. If I give it to you now, right? Okay, so it's good. I see it now. So we are doing that. So can you try to do the next one? I'm going to put it back. Do the next topic until we have within 8 minutes, we'll be going out of the class. It's very good you've told me that, so that you can practice. So what are you going to concentrate on? I'm going to put it back so that we can, where were we? Okay, so I'm going to look at the topics first. so that I'll tell you where we are concentrating. Oops. Okay, if you can see, okay, we are doing, this is topic 2. This is just background overview so that we know what is algebraic expression, what is degree, but it's really not part of our topic, our assessment. Now, what we did is solution to linear equations. You're given an equation and you're asked, find the solution of the variables, find the value of the variables. Then we did translation of equation to word statements. I'm not going to give you an assessment of this. I just want you to know how to do it. I've given you one slide there so that you will know how to understand this one. Translating these ones which you translated to words to be able to put it in a statement. So this is the one where this is where we are going to have this one, solution and translating to word statement. This is where we are going to have our assessment. So the topics we are doing now is this. This is the one, translating words to statements. So let's look at it. It's the one we've been doing. Okay, okay, so when you look at this, yeah, we jumped. This is, no, we did this one. So this one, I want you to practice. I see you can do it very well. So we had 2 topics here. You just practice how, if you can find the answers to these questions. When you come to class next meeting, you can tell me if you are able to do it or not, but I think you'll be able to do it. What did I say? Just remember, put the variables on the left and put the constant on the right to be able to find the value of x, solve for the value of x. Then when we went here, this one, no assessment. I just want you to practice to be able to say, you could say x decreased by 3 times y. X, the difference between x and 3y, or the difference between x and thrice y, or 3 times y. You know, things, you know, many ways of writing it so that you'll be able to understand this one. Like they say, find the number which when decreased, and you're like, what are they talking about? But you know already how to say things in words. So you know when they say decreased means minus. When they say increased means addition. When you say, but of course they'll say multiplied by, you know it's multiplication, or divided by, you know it's division. Okay, so like this one, the sum, we know what the sum is of 2 numbers is 80. The larger number is 9 more than. What does that mean? 9 more than, it means addition. The smaller one, it's 9 more than the smaller one, so it means it's addition. What is the number? So the question, they're asking for the number, not for the sum, not for the, so what is it you're going to do? Always give a variable. Give a variable to the unknown, which they're asking. What they're asking here, usually it's the one you're going to give a variable. I'll call it N, I call it B, I call it X, any variable from the English alphabet, any letter, okay? The sum of the ages of 2 sisters is 20 years. 2 years from now, what does that mean? It means I'm going to add 2 to their years. 2 years from now, it means addition. One of them will be 3 times. What does that mean? Multiplication, right? Find their present today. How old are they? Okay, so what are you going to do? Since they are talking about today, then you're going to say, I'm going to find their age today, the age of one of them. It should be so that you relate that sister to the other one. So if the sum of the 2 sisters is 20 years today, and one of them, the age is A, what is the age of the other one? You know, but you cannot use that because it will be difficult to think. the sum of the ages today. Then you say 2 years from now, the other one will be like this, like this. So you use that to, with the things you've been given, to come up with an equation. What is an equation? Equating that this side is equal to this side, to be able to come up with the value of the variable you're looking for. A man is 3 times as old. What does that mean? 3 times multiplication. When they say sum, addition. So you'll be able to come up with an equation. Okay, so most of the time you'll need to come up with a number of equations so that you'll be able to, and then relate this one into one equation so that you'll be able to solve for the variable. I am not going to help you here. I want you to brain twist. So this is your assignment. You're not going to give me the answers here. I just want you to practice so that you'll be able to do my sheet work and quiz. Now, when we come next meeting, we are going to be doing this one, inequalities. So I'm going to introduce you to inequalities. In this case, it's not equal. What is an inequality? Opposite of equation. So it's not the one side is bigger or smaller or bigger or equal to. So these are not exactly equal. That's what it means. So we are going to have some literature of that. And then we are going to have find solution set for our inequalities, which will be like what we are doing. But here, no more worded. I removed the worded problems. We deal with only symbols. So coming up with solution set will be also brain twister a little bit, but we'll be able to do it. Then we have our assessment. So you see already the assessment, sheet work, 30 points. This is, I think, theory. And then I think more theory. And then we have 20 points as our quiz. Theory. There is theory, there is there a theory? We'll see, I've forgotten, but it's like that. Okay, so it's, thank you so much, students, because you made me understand that it's too much to teach the 2 topics in one day. You made me realize that. So as I said, I'm sorry, because your class is always the first one. So what we are going to do, we're dealing with this today, next meeting this one, and then it will be on that Wednesday, Monday, you're going to be doing your sheet work, which will be submitted. I will see how it's going to be, because I might make it go over the week, but I'm expecting it to be submitted on Wednesday. On a Wednesday. Thursday. Okay, so that's it, students. Let's, okay. Not bad. Thank you so much, Mr. Trier, Ms. Anand, for telling me that. So now I understand. All my classes, I'm going to do the same. Only those 2 topics, and then the other one will be next meeting. Okay, so please get your hand out and read. You can read until the end to see what is coming up everywhere. Okay. Okay, let us pray. Miss Mendoza, Micaela, do you want to pray? Closing. Hello, Miss Micaela, you hiding somewhere? Okay, let us pray. We thank you, Lord, for the gift of, we thank you, Lord, for giving us the opportunity to learn and the capacity to understand. Let our knowledge be of service, not only for the attainment of our goals, but also for the benefit of others. Amen. Amen, amen, amen. Okay, thank you so much, students, for coming. So you go practice. You don't need to submit anything. Just read, practice. And if I were you, why don't you read inequalities so that you'll be able to understand it quickly? Because next meeting, for sure, you're going to have your sheet work, which will be submitted on Thursday. Okay. Okay, bye-bye.
Bye,
Thank you,
ma'am.
ma'am. Bye-bye.
Thank
Sayonara.
you. Thank you. Bye-bye. Bye-bye. Be safe. Have you seen your grades? Oh. Hi, Miss Turo. Hello. You still there?